Hey guys, we're back with more probability questions. We're talking about combinations today. And a great question to consider is playing cards, and you want to think about how many different combinations are there possible when a deck of cards is dealt to you. And we have our formula. We have n factorial divided by n minus r factorial times r factorial, and that is our combination formula. And we're going to go ahead and we're going to start with A. Please remember in this question, when we talk about a standard deck of cards, there's 13 cards in each of 4 suits for a total of 52 cards, okay? So here's our first question, and it says order is not important. Well, that's really key, because when it says the order is not important, that means you're not talking about a permutation, you're talking about a combination problem. So you want to use the formula that's above. How many different 5-card hands are possible? Okay, so we're just going to go ahead and plug in, and we know that there are 52 cards, and 5-card hands is our R. So we have 52 factorial divided by 52 minus 5 factorial times that 5 factorial. So we're just kind of like getting rid of that repeating element. And I'm going to go ahead and simplify this. We have 52 factorial divided by 47 factorial times 5 factorial. Well, that's equal to 52 times 51 times 50 times 49 times 48, all divided by, and that knocks out that 47 factorial, times 5 factorial, and that simplifies to 2,598,960 combinations. The second part we're going to consider is, in how many 5-card hands are all 5 cards of the same color? Well, a question like this, all you have to think about is, you're holding a deck of cards. Well, what colors are there in a deck of cards? And there's black and there's red. Okay, so it looks like we're talking about one of 2 colors. So the first C in my combination formula is, we know that there's 2 colors and we want to consider one of them. Okay, and we want to multiply that times, and this is kind of like using our fundamental counting principle right now, and we want to consider, well, half the deck of cards, because if we're talking about all black or all red, well, all black there's 26 cards, all red there's 26 cards. So my n in this particular example is 26, because half the deck would be either black or red, and we're talking about 5-card hands, are all 5 cards are the same color. So my R in this particular example is 5, and that's going to be 2 factorial over 2 minus 1 factorial times 1 factorial times, now we're looking at the second component here, and we're just plugging in with our formula, 26 factorial divided by 26 minus 5 factorial times 5 factorial, and that simplifies to 131,560 combinations. The big nugget that I want you to take away today is, when you're trying to distinguish between combination problems and permutation problems, when it says order is not important, we know that's a combination problem. Okay, you are welcome. Have a fabulous day.